Hi. Okay, now there's sound. I'll be right back. Hello. All right. Well, let's go, Justin. What's up?
Hello. Professor?
Yeah, hi.
Hi. I have a question for Project 2D,
Yeah.
specifically for like the map thing that we're doing. Are we supposed to, what I'm confused on what we're supposed to do for part one of the project. And like I read over that piece of the spec, but I'm still a little confused on what we're supposed to do.
Let me look at it again. It's been a while since I've done this one. Sure. Okay. So, all right. So you are supposed to, let's see. What do you want me to tell you?
I'm just not sure what we're supposed to do. Like, are we supposed to make a new file and then implement that? Are we supposed to go into our old file and implement that there?
Got it.
What are we
Where's the
supposed to
code
name
going?
the file? Yeah, where's the code going? And then like what exactly we're implementing? I was a little confused by the text.
Yeah. So in raster API handler, let me open up this starter code real quick. Actually, so I guess my first question is, have you watched this?
I have not watched the videos. I did read over the spec.
Okay. Let's see if I have any comments that are useful. And I think I watched these videos first because I explained it better then, and I'll explain it now probably.
Okay.
Yeah. I mean, let's see. Yeah, I'd watch these first because
Okay.
They go over it. Yeah, sorry.
Okay.
If we have more time later, I can maybe talk about it. But those videos do kind of give an introduction to everything. So I'd start there, then come back to the still stuff.
Cool. All right. And then second question is for the final, how would you recommend I go about prepping for it? I tried to get a study group like you said, and I'm working on that currently. Yeah. Is there anything else you'd recommend that I do to prep for the final?
Sure. I mean, really it's all about like beating your head against these B-level and sometimes A-level problems. That's where the learning happens. Bonus points if you can argue with other people, as you've been discussing about study groups. But it's really about hitting the wall and then getting over the wall as many times as you can. There's a big difference between looking at a problem, understanding what it's asking, and then reading and understanding the solution. That's one approach. And the other is looking at a problem, trying to understand it, working at it, getting totally stuck, coming back to it later, still being totally stuck, coming back to it later, still being totally stuck, and then finally solving it. You don't want to waste a ton of time, but that process of exploring all the options is where you start to fill in all the little gaps in your knowledge. Because any little problem is basically just one little sample in a giant space of all the things that one might possibly know. And the way that you fill in the gaps, I think, is by aggressively exploring the space, trying to find solutions to really hard problems. That's just my
Okay.
side. Yeah.
Okay, cool. And then my last question of the day is, do you know anybody that like one of the TAs maybe that's like, or GSIs that's like really good with JavaScript web-based development? I just have some questions I'd like to ask them if there's anyone you know that I could reach out to.
I'll ask. Let's see. BTW. All right, cool. I just put a post out on Slack, so I'll let you know.
Okay, cool. Should I email you if because I might have to get going right now. Should I
Sure, go
email
for it.
you
Yeah, go
afterwards?
for
Okay,
it.
cool.
Email me and I will hopefully email, like my email box is always Niagara Falls, so things get lost in it, but please do.
Okay.
And I
Okay,
never
cool.
mind it, by the way, if you ever send me an email that's just saying, just bumping this to the top of your inbox. That's totally fine. Like,
Okay, cool.
yeah, cool.
All
All
right.
right,
Thank you.
you got it. Viverd.
Hi, Professor.
Yo,
I had a question about the part one of the project we're doing right now.
2C or 2D?
2D, the
Okay,
map
got it.
2D.
Cool.
Yeah. So on that, I saw that on the Project 2C video in the slides, you suggested we first figure out the correct depth for the query and then
Say
have
again.
um in the some general tips part of the slide.
Yeah.
You said that we can figure out the correct depth for the query and then
Yep.
figure out how to compute the bounding box.
Yep.
So I have a question about computing the bounding box. I think, or I'd like to think that I got the depth part right.
Yeah.
But at first I thought that the bounding box, like you just had to assign it to like the to like the latitude and longitude stuff appropriately. But then I think we had to scale them somehow because the all of these are in like x0 and x1 and x2, not like weird long latitude longitude coordinates. I was confused
Yes,
how to do
correct.
that.
Yeah. So you need to move basically from, as I recall, one coordinate system to the other. Let me look at my slides real quick so I can page into this thing. Okay, so. Okay, so your question was, you're noting that in one coordinate system we're using, negative 122 or whatever, and the other we're using like 7.
Yeah.
Yeah. So what was the question?
So, so like I was wondering how I could go about converting from coordinate system weird decimal to coordinate system 1 to 7.
Sure. Well, it's all about kind of working out the math because of the fact that the leftmost edge of the universe, right? We know the minimum longitude and the maximum longitude, and we know the minimum x and the maximum x. And so just using those two facts, you can kind of work it out, right? Like suppose that your, what is the variant, let's see, what is the minimum lat lon?
So I'm sorry to interrupt you
Yeah,
if
go
you
ahead.
were gonna say something,
Yeah.
but would you? I don't wanna. Okay, so I'll just straight. So would it be a good idea to find some kind of dividing factor between 0 to 7 and the longitude, min and max, and then use like assign it to an array, and then when I need the box,
Uh-huh.
then I get the appropriate
I don't really
item.
think you need to like store it in an array. I mean, a helper function might be a more natural thing to do rather
Yeah,
than storing a bunch of pre-computed things in an array. And also, by the way, when I said 7 earlier, I was kind of referring to the wrong thing because that's depth, not x or y, right? Like it should be ln corresponds to x and lat corresponds to y, right?
yeah.
Yeah, but given a particular longitude value and a particular depth, you can compute the x because you know where, like let's imagine that the minimum ln was negative 122. I can't remember what it actually is, but it's some number. Let's see, where is it said? Min. Yeah, here we go. Wait, no, not ln, minimum ln. I know it's in the starter code, but I'm just gonna go to it real quick. Okay. So project 2D. Okay. Um, route handler. Oh yeah, funny. All right, here we go. Constants. Wow, this stuff got major refactored. I forgot about how Rahul did that. Anyway, so you know that the lowest possible longitude is negative 122.299. So values that are just a little bit above this would all have x of what?
X of 0.
Correct. And as you move your way towards the right, eventually it'll get up to x of what?
I'm not sure what the maximum is, but
Depends on the depth, right? So if the depth is
oh yeah. So
yeah.
like because it's like 2 to the d to power minus 1.
Mhm.
So yeah, okay, that makes
Yeah.
sense.
So using that kind of thinking, you can work out a way to compute the x and the y given the root values, the depth, and the current position. That is, given a longitude and a latitude, you can write a function that takes these values and the depth and computes an x and a y. Does it make sense?
Yes, that makes sense.
Yeah.
Thank you.
Yeah. For a long time, there was a controversy in the old days about whether that was the best way to do things. We had an alternate approach that used the quad tree, but this way just makes more sense. Oh, let's see. Someone mentioned this topics in pink will be only sea level. Tentatively, actually, we're going to make them not on the final at all, just FYI. So anyway, we're probably going to do that. We're going to put out an announcement this weekend. So anyway, Vivur, do you have another question?
No, that's
Okay.
it for now. Thank you.
Cool. Anya.
Hi. I had a question about the quick sort algorithm.
Uh-huh.
I'm just a bit confused what's happening, like what it means to partition on an item and
Sure.
how that whole tree of calls is created.
Well, we'll just start with partitioning.
Sure.
So the actual idea of partitioning, does it make sense what it means?
I guess like the thing that you're partitioning on is like a wall. I don't know, and you partition
Well,
the left half and the right half.
let's get less abstract and use an actual array real quick.
Okay.
So let me share my notepad window and I'll say, what if I have the array 6, 1, 2, 9, 7, 3, 7, actually do 5 or something. Okay, so let's suppose I partition the array below on 7. Okay, what does that mean? Well, here's a question for you. Is, let's say 1, 2, 3, 3, 5, 6, 7, 9. Is that a valid partitioning on 7 of that array?
I think so.
Why do you think so? I mean, I'm happy to describe for me why.
Yeah, so I guess everything to the left of 7 is like less than or equal to 7.
Yep.
And 9 is greater than 7.
Great. That's all. Okay, exactly. Yes, because everything to the left is less than or equal to everything to the right greater than or equal to. Okay, so that's one. This is one particular partitioning. All right. Let's take this original array again, and let's say we, if we partition this on 5, we might get. I'm just gonna pick a random ordering. 1, 2, 3, 3, 5, 6, 9, 7. It's not a random ordering, but it's something. All right. Hold on. I'm going to take this original array and change it because I don't want it to look too nice. Okay. I'm changing the problem retroactively. All right. So if we partition this array on 5, we might end up with this array, potentially, right? If we partition. This is a valid partitioning, correct?
Yeah.
Okay. So is this array sorted? No. But what can we say about 5?
It's in the right spot.
Great. All right. So what that means is I don't need to sort 5. So I just need to get this sorted and this sorted. Okay. Now to sort 2, 1, 3, 3, we could do any sort at all. We could merge sort them. We could insertion sort them. We could selection sort them. Or we could partition the array on one of the elements and see what happens. And the point is, every time you call partition on a given element, like hopefully you agree that if we, so let's call this operation, if we call partition 5, we might get that. Observation, if we call partition on every single element, the array will be what?
Sorted?
Correct. So what quicksort is all about is calling partition on every single element until the array is sorted. Now, the big thing that makes quicksort special is that when you partition 2, 1, 3, 3, you don't need to look at 6, 9, 7 because you know that all this stuff is less than or equal to all this stuff. So there's no way that they're going to need to like switch places. So you basically sort of like merge sort. You've broken it into subproblems. So we have a left problem that's just 2, 1, 3, 3, and a right problem that's just 6, 9, 7. That's quicksort. So that thing you were saying, it's the partition element acts as a wall. What I mean by that is that none of these items are ever going to end up over here or vice versa.
Okay.
Does that make sense?
Yeah, that does. Thank
Okay.
you.
So that is quicksort. That's all it is. So then you had another question about the tree, something, something, something.
Yeah. In the slides,
Mm-hmm.
I think as you were going through the demo,
Uh-huh.
the quicksort demo, there was like a tree of
Calls.
calls to the partition method. Or,
Yeah.
I was just wondering where that
Got
came.
it. Let me try and find it.
Sure.
This thing?
No.
okay.
There was a separate link for the quicksort demo.
Demo. Okay. Yeah. Yeah. Okay. Yeah. Here we go. All right. Got it. I see. All right. So let's talk about it. So that I'm just putting it, this tree, you're wondering like what it means or why did I bother even creating it?
Yeah.
Basically, sure. It's just basically keeping track of what we did. So when we partition on 32, 32 ends up in its place. And they have two subproblems. One that has these 1, 2, 3, 4, 5, 6, 7 elements, and this one that contains this one element. When we partition on the left, which element are we going to partition on?
I guess the middle one, I think.
Actually, no. The algorithm as I'm describing it here always uses the leftmost.
Oh, oops. Okay. Sorry.
Yeah. You want the median. That's the ideal, but yeah. But our
So-
algorithm always picks the leftmost.
Okay.
So, yeah. So basically the next partition that happens is 15 is going to be the root, or sorry, 15 is going to be the partitioning item on the left, and 41 is going to be the partitioning item on the right.
Okay.
Does that make sense?
Yeah.
And so that's why we have 15 over here. Now, I didn't show all the intermediate details, but if you were to repeat that same process over and over, you'd end up with this. And this tree basically showed all the subproblems that, so when you're here, right, the left subproblem starts by partitioning on 15. It will create two subproblems, one that involves partitioning on 2 and a right that involves partitioning on 17 and so forth. But I didn't show all this because it just seemed tedious and unnecessary and doesn't actually tell you anything. Though I can see why this tree was confusing. And then the right subproblem was partition on 41. Let's see, hold on a sec. Oh, this is the long version. Okay, that's right. I have the long version in here too. So if you watch the long version of the demo, you can see it, the tree get generated like so. Is that helpful?
Yeah, that is helpful.
All right, cool. Yeah. And what's fun about this that I mentioned later is that if you look at this, this is actually a binary search tree of the data in the array. So that's kind of cute. So it turns out binary search trees and quicksorts have a secret connection that was not obvious to me the first maybe 4 years I taught this class. All right. Did you have other question on quicksort?
No, that's it.
Okay, cool. Quicksort's my jam. I like it a lot. I can tell you plenty more about it. All right, Andrew.
Hello. I was looking at project 2D on part 2. It said we could use a KD tree.
Yes.
How do we convert from long and lat to X and Y? Because the KD trees are set up for Euclidean distance, and long and lat would use Haversine distance. So it's weird.
Oh, I see what you're saying. Yeah, the Haversine distance versus Euclidean distance, it's not that big of a difference. Like the actual distances are very close. So you don't need to worry about the difference.
Okay, because what actually happened was when I ran the when I just imported my KD tree and I ran it, I had test fail. Then I went back and changed into like my naive point set because I wanted to see if my distance was wrong or if like something else was on. And I changed the distance formula to the Haversine distance formula.
Wait, well, I'm trying to
and
remember
then
that.
it passed everything.
Interesting.
So
I gotta think about this then. Point. Yeah. Huh. Okay.
Because-
I remember it wasn't that big a deal, but I guess it can make a minor difference. So I need to think about this again. Haversine distance. Okay.
Because then pruning would also be weird because I then enter the Haversine distance formula into my KD tree, but then pruning gets a little bit skewed because now you're going on a sphere.
Yeah, this is a great question. I'm trying to remember what happened here in terms of I need to do a tiny dig into, I'm gonna look at our old Piazza because I remember thinking about this. It's been too long. So I'm just gonna go look at the discussion.
only thing I could think about is if you created a helper method to convert from lat and lon to x and y, but I don't think there's like a good way to do that.
Yeah, I don't remember. Give me a moment to try and remember this detail. Okay. So what were you failing, by the way? One of our
The router test. Like
Another router.
test 4 through 7 or so.
Yeah.
But when I Googled like the Haversine distance formula and I put that as my naive point set distance formula, and then everything seemed to pass.
Oh, I see. So you went and dug up the Haversine formula. We don't even give it this.
Yeah,
I couldn't remember.
I like literally dug it up because I was really confused, and since I finished it, I was curious.
Oh, I see. Wait, so if I'm understanding correctly, what you're saying is that when you used our points distance formula, the local tests we provided you were failing, but then when you swapped out the given distance formula in the point class of the Haversine distance, then it worked correctly. Is that right?
Yeah. There's a given distance in the point class. I might have also just misread some.
Yeah, I mean, I need to look real quick. All right, it's been a while.
Oh wait, there is a given distance in the point set. No, I was using my KD tree with the point just the distance generically set to Euclid distance.
Ah, I see. Okay, got it. Yeah, no, the assumption is that our point class, let's see, for 2D.
I did not know a point class had a distance. I need to read more.
That's okay. I mean, these are, this is the most Paul Hilfingery project of the semester. So it's got that, there's a lot of stuff to dig and find. Let's see, distance.
Yeah, okay. Now, that makes a lot more sense because how I was doing it was I would just, because a KD tree was initially only set up for Euclidean distance.
Yeah.
So I would just using square roots and squares. And I didn't know that the point class had its own separate.
I see. Okay. Cool. Good. All right. Wow.
That makes a lot more sense.
I'm glad that we dug that up. Thank you for noting that. It's very useful. All right, Lydia.
Hi, I was wondering if you could go over the midterm to question 8, number B.
Okay, 2
or part B.
Yeah, 2A. Let me download the PDF copy of this midterm real quick. Here we go. Oh, I see. No, I don't want to restart my computer. All right, there we go. Okay, let me share the right window. All right, which one? 2.
Question 8, part
8. Yeah.
Part B.
8B. Okay, sounds good. So as one is trying to work your way down the tree, actually, I mean, do you want to talk? I can do it either way. Oh, also, you had weird symbols, right, as opposed to letters. the version you have has Greek letters here, right? Instead of alphabetical letters, is that correct?
I think so.
Okay. I think it's fine. It'll be clear. Okay, so did you have any sense of how to approach the problem, or do you want me to go totally from scratch?
I mean, I guessed on it and I got some right, but I was wondering if you could just go through it because I didn't know how to approach this part.
Okay, sure. So you weren't quite sure how to approach it. So I'll ask some leading questions to help you get there. So the question is, so when you try to find all the points that live inside this rectangle, you have to use this tree, right? So you have to start somewhere. Where do you think we should start?
So I was like, I just didn't know how to approach it at all.
Got it. So the idea is you're given a tree here that like
Right.
So anytime you're given any kind of tree, presumably you only have a reference to the root, similar to on project 2A, you have the root node, right? So you have to start at A and you ask yourself, is A inside the rectangle? So is it?
For A, in which rectangle?
In the query rectangle, the box that we're trying to.
No.
No. Okay. So A is not in there. And then you need to keep looking for more points. So A has a left child and a right child, right?
Right.
Okay. So if we go left to E, is it in the rectangle?
No, it's not.
Okay, now here's a question. Did we need to go left?
Yes.
Okay, why do you think we needed to go left?
Because we had to visit the child of A, both of them, right?
Got it. So we haven't visited them all. However, here's where pruning comes in. So similar to nearest in project 2A, you don't necessarily need to search the entire tree. So if do you remember the pruning rule from project 2A? I mean, you might not have digested it fully, but do you remember at all how it worked? It's fine if the answer is no, by the way.
No, not really.
Okay, sure. So looking at this, one thing I'll observe is that, okay, so A, right, it has a left side and a right side. It basically divides the space into a left half and a right half. And this left half is all these points that are to the left of A, and on the right half is all the points that are to the right of A. So what I would argue is there any, actually question for you, is there any way that a point to the left of A could be in this box?
No.
No, right? So that's why you can prune A. Did that make sense?
Yes.
Okay, so I have homework for you. Given what I just did, try and do the rest of the problem and then come back Monday. And if you haven't figured it out, then I'll be happy to go through it.
Okay, thank you.
That's the heart of what you need to know. All right, cool. Kushi.
Hi. So this is just like, this question doesn't really matter, but like I just wanted to. So I used a KD tree for like the second part of Project 2D. But when I looked at the weird point set class, I was just really confused, like what's happening there.
Got it. You looked at what?
The weird point set. Like they said, use a KD tree or like a weird point set.
Sure. The weird point set is just there if you don't have a good implementation of KD tree that you feel good about.
Yeah.
So it's just there for people who didn't finish part 2A.
Okay.
Yeah. And it is intentionally weird and should make totally no sense because what we didn't want to do was provide a solution to the project that people would use the next semester.
Okay, got it.
Yeah.
I was just.
If you look at it, it's just, really strange.
Okay, cool. Thanks.
Yeah, it's just, intentionally obfuscated in many terrible ways. It is actually just a KD tree, by the way, but an obfuscated implementation. If you haven't looked at it, here it is.
Yeah, I've looked at it. It's really weird, but I get it. Okay.
All right. Next. Any more? Oh, yeah, here we go. Sufi.
Yeah, so just to follow up on 8B, I put J, so I put A, I, E, and then J, and I know J was wrong, but I wanted to like walk through why it was wrong, and I don't know why like I put it on there, but so would J be wrong because we still would want to check 4?
We would still want to check basically this subspace that I'm tracing out with my mouse, because this is everything above D. So the D basically splits the universe into two half spaces. One, which is this rectangle, which is finite in size, and the other is this rectangle, which has the infinite top. Right? Does it make sense?
Gotcha. So we want to check. Okay, so we want to check everything above like 3, which is the like y coordinate because like it could all go all the way up till 7.
Yeah, it could be basically that maybe there's a point here, right? Like point X or something is right here. And that could be D's right child.
Okay.
Does it make sense?
Yeah, it does.
Okay.
Thank you.
Yeah.
Can I ask a follow-up on that?
Yeah.
I missed. So was J supposed to be pruned or not?
J was J was not supposed to be pruned because you do need to actually look above D because there could be points above D.
Right.
Makes sense? Because basically this rectangle, it intersects the space, the top space controlled by D.
Mm-hmm.
Does it make sense?
Okay, but I would be pruned, right?
Yes, correct. Yeah, because basically this rectangle down here, or sorry, this rectangle that I'm tracing out would be not intersecting this big box. There's no way, in other words, that anything down here could be in this box.
All right, thank you.
Let's see. Share real quick. Okay. I'm gonna make quick notes. Okay. All right. What's next? If anything. I'm curious how everybody is feeling in terms of being stretched thin. If anybody has any comments.
I'll be fine as soon as Thanksgiving break rolls around.
Well, I'm hoping that the class doesn't feel too heavy in the last 4 weeks. Because I've the pink lectures, I mean, almost certainly what we're going to do is say they're not on the final. So that gives you flexibility not to feel stressed out about that. Got a partner project that I hope is more fun than it is stressful. And yeah, well, I'll cross my fingers and hope.
Wait, are they not on the final or are they just like really easy questions?
No,
really?
I think we're going to change them so they're just literally not on. I'm almost certain we're going to do that. I mean, this just came up because the P&P decision, like I just want to make sure that if we're going all out to the point where people are doing PNP, I want to feel like people who are, sounds like people are really like having a bad time. And I'd like to make sure people can still learn these topics if they like. But I think I'm okay with letting it go and saying they're not on the final of the semester. So, I mean, I'm assuming that would make your life less stressful, right?
Yeah, no, definitely. And I know that's like what 61A I think did last semester is like it cut out a couple of lectures that we just didn't have on the final. So it was easier just to watch those just like for learning's sake.
Totally, right? So, I mean, I got the okay from all the TAs. So I mean, unless something crazy happens, well, we're definitely doing it. We haven't put it out as a formal announcement, but since you're here, you could be the first to know that almost certainly we're going to make these just fully optional. But I think they're really fun lectures. Like, don't miss these. I love my software engineering lectures. They're really good. And I should really remind people to watch them before they do Project 3A, because this lecture is pretty useful for bear maps, and this one's very useful for Project 3, the one that I may or may not be screen sharing right now. I am not. Yeah. This one was built partially to help with Project 2D. I guess I never actually told you that. And this one is today's putative lecture is very Project 3 focused. So even though they won't be on the final, I still think that they're good. Worth watching, that is.
Will there still be like check-in quizzes for those?
Oh yeah, I'm gonna keep making check-in quizzes, yeah.
Okay, great.
Yeah. They take surprisingly long to write though, but I learned that when I outsource these kind of questions, I don't think the TAs ask the right questions. They're quite lovely in many ways, but yeah. The thing I was surprised by is I can't really let TAs write homework. Like if I let a TA write a whole homework question or homework or even a whole lab. It's really hard to get right. Anyway, Phoebe.
I had a question about Project 2D Part 2 in the closest method that takes a lon and a lat.
Yeah.
So it says that the method needs to complete in log n time.
Yeah.
If I'm adding items to a KD tree, wouldn't that be n log n?
Let me look real quick. Sorry, it's which method?
Long closest double lon double lat.
Okay, double lon. Closest. Sorry. Okay, so when you do, you're worried about the runtime of closest?
Yeah, I'm wondering if I'm able to create the KD tree in the constructor. It just doesn't tell us that we can use the constructor, so.
Oh, I see.
I didn't want to break.
So when you create the semantic street map graph, yes. Okay, let's see.
I think I saw that somebody said you could do that on Ed.
Yeah, I mean, you should build a KD tree somewhere. Where's the log requirement? Okay. Where'd that requirement come from though? Because there's, okay. I mean, it's basically true, sure. I mean, you shouldn't create the KD tree when someone calls closest, no, because that will be slow. So you should have the KD tree already ready to go.
Okay, so we can just construct that beforehand.
Yeah, you want to have it built beforehand because it's going to be static, and then all future queries to closest will be, by static I mean unchanging, not literally static. Yeah.
So do we call the KD tree in the constructor of the augmented?
You create the KD tree in the constructor?
Oh yeah, you create the KD tree in like the constructor. Okay.
Yeah, that seems like the right place to do it. Yeah.
Okay, thank you.
All right. What else you guys got? Does anybody watch today's lecture out of curiosity? It's not, obviously imminent, but cool. What'd you think?
I thought it was really cool.
Yeah, I mean, it's like, I feel really proud of these lectures, so I really want everyone to watch them. Yeah.
I thought it felt real world applicable.
Yeah, it's like, I think the best thing I did last spring was realizing I can cut some of the technical stuff and talk about more software engineering, and it's just way more interesting and applicable to people's lives. I wonder what I cut. I don't even remember. Oh, look. Guess I cut. Oh, I see. Okay. Let's see. Let's go back to spring before I did the revision. I cut dynamic programming because we didn't really talk about dynamic programming. I cut a lot of Java stuff earlier. There used to be 3 extra lectures of Java at the beginning about things like packages. That was boring. About generics and auto boxing. That was boring. Yeah. Access control, also boring. So I think I cut, that's right. I cut a bunch of early topics like Java language stuff, got rid of them, cut a little tiny bit of algorithms, and then gave you software engineering instead. Okay, good idea, me. I'll take questions about literally anything. We got 10 more minutes, and we seem to have exhausted our 61B questions. If you have other stuff. And I can handle an awkward silence. Anthony, go for it. Uh-oh, you're very quiet. All right, I can't hear you. Ah. I heard a tap noise. Oh, here we go. Oh no, you're still yeah, just write it in chat. Yeah, for some reason your volume sounds very faint. Ah, okay. Which images to choose for the query? Well, you got to break it down. And so what? Yeah, sure. So have you identified, for example, how to figure out the depth? You can give me a thumbs up if you want. All right, cool. So then where are you now? Like, do you have a sense of, so once you know the depth, you need to figure out which X's and Y's to use. Do you know how to find any of the X's and Y's? Like say I said, write me a function that just gives me one of them. Do you think you could do that? It's fine if the answer is no, but trying to get a sense. I know this is hard to do with chat. It's very awkward. Got it. Okay, so then my question back to you is, let's see. Well, earlier when we were talking to, I forget who it was. What I'd said was that we know the minimum. I'm gonna go back to that constants file and I'm gonna open up, oh, sorry, no, wrong thing. I'll share my screen in a sec properly. Okay, 2D, skeleton, static, no, pair maps, 2D, constants, okay. So what I was saying, like the example I gave somebody else earlier was, let's say the, or actually, sorry, I'm gonna give you one hint, and I don't know if you've thought of this already, which is to think about if someone gave you not a box, but just a specific point. Like if I said, I have latitude, I'll give a suggested exercise here, which is, if someone gave us the point, I'm gonna pick something real quick. I'm grabbing one more thing. And said, what is the right, as X and Y for depth 5. This is something I would try and work out. Because if you could do that, you have a way of converting from latitudes and longitudes to X's and Y's. I don't know if that's something you've considered trying, but I think it's a good building block exercise as one works their way towards a solution. Does it make any sense, Anthony? Nothing, no sound. It's totally blank. Well, it's not that the pixels are converted to X and Y coordinates, but it's the latitudes and longitudes. Right? Like, and when I say X and Y coordinates, we mean, oh, you shouldn't be thinking about pixels, by the way. Your code isn't thinking about pixels exactly. In Get Map Raster, your job is to, given a query box, right? If we go to the skeleton code real quick, and we look at, okay. Where's your code?
Can I ask
Yeah.
a question?
Go ahead.
Is the negative 122 comma 37, is that like latitude and longitude?
Yeah, this is the latitude, longitude, and this is the latitude. Yeah.
Okay.
Thank you.
Yeah. Let's see. One sec. Get process request. Yeah, right. So someone gives you a request, and that request is going to include a lon, a lat, a lon, and a lat. You don't think about pixels at all. Yeah. You don't need to convert to latitude and longitude because you're given a latitude and a longitude, right? So someone's going to give you the latitude and longitudes that they care about. Does it make sense? I guess one other thing I'll mention, yeah, okay. Yeah, so one other thing I'll mention, if you have not already, let me look at my slides again real quick. Oops. Okay, I mean, I would basically, let me see if I can find my favorite example. Yeah, okay, right. So at depth 7, this latitude and longitude corresponds to x84 and y28. Like, you really want to understand how you could write code that goes from this to 8428. That would be the exercise I recommend. I don't know if that's helpful. All right, I'm gonna pivot to Phoebe's question here. Yeah, how multiple computers can access and change data that's stored on a server. So what usually happens is there's some system somewhere that's able to receive, there's a few pieces here. Let's see. So in this case, you could actually do it with this code base that you have. Let's take an example, which is if you had this code running on a cloud, like on a computer that was internet facing, and you started receiving process requests, right? You could, in principle, be writing data out to some files. So you could use, for example, the out class that we used in Project Zero to generate text files. And you could record all of the requests. You could even print out the previous requests that people made. So the question is, how do you actually get these requests from the internet? There are libraries out there that will basically interact with your operating system and allow you to receive, information from the internet via something known as a port. So basically, if you have an open port, your computer is listening, and when it gets information on that port, it'll pass it to the appropriate code that's running. We haven't actually showed you how to run this code in an internet-facing way, but it's actually, we're pretty close with this. Yeah. Ports. So in this case, you could do it with your laptop actually at your house. If you were plugged into my home internet, I could run a web server on my desktop computer sitting right next to me, and people could connect to the ports on my computer. In particular, actually, let's see. So right now, if we look up what is my IP, you can send me some packets if you want. If you ping, this address is me. So if you open up a terminal, I'm not sure if I'm sharing my screen properly. And I will have 2 more things to say before we go. So right now, if I open up a terminal and or if you do the same thing, you can ping my computer if you'd like. I don't mind. Hold on, I gotta move this. Okay. Oh, all right. So if you do ping me, So then you're sending me some packets. And if I had if I had a web server running on my computer, and you went to literally, like if you just typed in this here and did 80:80, it would try to connect to, in fact, let's see, is it gonna work? I don't know, probably not. Oh, hey, interesting. All right, so if you do this address, I don't know if you'll be able to try. Actually, I'm kind of curious. Can someone try doing that? What happens if you go to this address? I'll put it in chat, and then you put :80. Yeah, Suvi, can you just send me another email to put it up to the top of my inbox, by the way?
Yeah, will do.
Yeah, okay. What happens if you click that link? Does it resolve or not? I don't know if it will.
Oh, you sent it privately to me.
Oh, I sent it to you. Ha ha ha. Okay. Nope. Nah. Sorry, one more time. That last one. What happens if you click that? Anything? Oh, it might say it's unsafe. So maybe I'll take the H out. One more. Does that bottom link do anything for anyone?
No, not for me.
Okay, so it's not set up to accept traffic from the outside world. But if I say what?
It's just loading forever.
Okay, got it. Yeah, so it's just stuck. But if I had a web server running, then it would start reacting to whatever you're doing. Now, in the modern era, it's not that common to run web servers out of your own house. And so typically what you can do is you can use a cloud provider. Well, they'll have a computer set up there for you. Running a web server out of your own house costs nothing. But if you are serving, gigabytes of traffic or whatever, your internet, like if you have Comcast, they'll get mad at you. But yeah, it's in principle, you can just run it on your own computer. If you want to play around with creating a cloud computer that you can connect to, DigitalOcean is what I use for running Beacon. So, of course, Beacon is like some software that we ourselves wrote, and we have it running on a DigitalOcean droplet, where it's just a server in the cloud that's out there. That's not in any of our houses. One quick funny story is that the Coursera version of the algorithms class at Princeton, at one point, the grader that Coursera wrote broke. And so I just redirected all the traffic to my desktop computer at my house, and then it just ran the grader out of our closet for a little while. Anyway, that's only a partial story, but yeah, one of these days I kind of want to set up something where you can build a piece of software that's actually a server, and then like I want to make Project 3 multiplayer eventually, where you can join each other's worlds. So if that happens, you'll be able to do that sometime. All right, I think that's that for now. So good luck to everybody. And Anthony, if you haven't watched all those Project 3 videos, make sure to do that. I didn't ask earlier, but all right, I'll see you guys on Monday, and talk to you later.
Thank you.